Hey there, Chickadee! In this video, we will be covering the topic exponential growth and decay. The target of this video is to be able to understand the concept and learn how to solve the word problems of it. Population growth, pandemics, compound interest, and spoilage of food. These are all of the examples tackled in this topic. For many students, the concept of exponential growth and decay might sound confusing, but don't worry, we are here to help you. Once you get the hang of it, you will start to realize that the logic behind this topic is quite simple. So, what are we waiting for? Let's dive right in. Firstly, let's talk about exponential growth.
Let us take a look at the given formula for exponential growth.
Y is equal to A multiplied by the quantity of 1 plus R raised to the x power. When A is equal to the initial value, R is equal to the rate of growth, and X is equal to the number of time intervals that have passed. Sounds quite confusing, right? Let us use the turtle population as an example to explain how this formula works. Let us suppose that we have 300 turtles on an island in the year 2020. If the population grows by 12% every year, how many turtles will there be in the year 2025? Since the initial value is 300, A will represent 300 turtles that are currently existing on the island. It was mentioned that the population rate of growth is 12%, so should we input 12% here? No, we shouldn't. Always remember that we have to change the percentage into the decimal form, so this will give us a value of 0.12. Lastly, let us identify the value of x. What is our time interval? Yes, you got it right. We are looking for the turtle population in the year 2025. With that being said, our time interval will be 5 years. Therefore, it is y is equal to 300 multiplied by the quantity of 1 plus 0.12 raised to the 5th power. And now that we have our complete equation, let us solve for the population of turtles. Firstly, do the addition inside the parentheses. Always remember that the expressions within the parentheses are evaluated first. Not following the correct order of operation could mess up the whole computation. Now let us get back to our discussion. 1 plus 0.12 will give us 1.12, and raising it to the 5th power or multiplying 1.12 5 times will give us 1.76. Now, we are left with a simple multiplication. 300 multiplied by 1.76? That's right, 528. There will be 528 turtles on the island by the year 2025. Within the 5 years, the number of turtles will increase by 228. Isn't that amazing? See? You are getting the hang of the exponential growth. You just gotta keep practicing. Let us now get ready for exponential decay. So, what about this? The mechanism of this is pretty much similar to exponential growth, except that you use subtraction. Let us give you an example. Y is equal to A multiplied by the quantity of 1 minus R raised to the x power. When A equals to the initial value, R equals to the decay rate, and X equals to the number of time intervals that have passed. Let me explain the logic behind this formula. Suppose that the number of COVID-19 cases in a city declines by 21% every year due to the availability of vaccines. If the initial value of cases in the city is 150, how many cases will there be after 8 months with an assumption that the patients cannot recover without the vaccine? First of all, it was explicitly stated that our initial number of COVID-19 cases is 150, and our decay rate is 21%, which can be rewritten as 0.21. Because remember, we always need this in decimal form. What about our time interval? Yes, that's it, 8 months. We got y is equal to 150 multiplied by the quantity of 1 minus 0.21 raised to the 8th power. Now, it is time for us to solve it. Feel free to pause the video if you want to try to solve it on your own. Let us start with the values inside the parentheses. 1 subtracted to 0.21 will give us 0.79, and 0.79 raised to the 8th power will give us 0.15. Lastly, 150 multiplied by 0.15 will give us 22.5, or if we round it up, it will give us 23. The vaccine was effective and was able to reduce a great number of cases. Here we have a few examples for you to try out. Feel free to pause the video and try answering them on your own. Amazing! We were able to tackle the importance of the concept of exponential growth and decay, and also the relationship between their mathematical concept and our real-life situations. Moreover, we learned how to solve the word problems using the data given to us. It might seem a little bit challenging at first, but as you keep practicing, it'll get easier. We hope you enjoyed today's session, Chickadee. Thank you for watching this video. See you next time!